Now we'll consider the vertical translation. The vertical translation can be written as f of x maps onto f of x plus c. And we'll use as an example function x squared maps onto x squared plus c. So by changing the value of c, we can see that we can move the graph of the function upwards or downwards. Notice that the shape of the graph is not changing at all. When we have an intercept which is less than or equal to 0, we have real roots. F of x equals x squared will have a double root at x equals 0. But as soon as we have a translation downwards, we'll see that we cut the x-axis in two distinct places. We have two real and distinct roots. On the other hand, though, in this case, if c is greater than 0, as soon as we move the curve above the x-axis, we don't have any real roots. Let's have a go at some examples for ourselves.
To summarise on what we saw in the animation then, the vertical translation can be written as f of x maps onto f of x plus some constant a. In this translation, the shape is unchanged. The graph will move upwards if a is greater than 0 and downwards if a is less than 0. Let's have a look at an example. In this example, we're given the graph of some function f of x, and we're asked to sketch the graph of f of x plus 2. We can see from the graph of f of x on the left that we have the coordinates of 3 points, the vertex at -1, 2, the root and the y-intercept at 0, 0, and a second vertex at 1, -2. In order to obtain the transformed graph, all we have to do is add 2 to each of the known y values, as it's simply a vertical translation. So the first point, -1, 2, will translate to -1, 4. The point at 0, 0 will translate to 0, 2. And the second vertex at 1, -2 will translate to 1, 0. The shape is going to be the same, so we can sketch in our curve like this. Now have a go at the multiple choice question.